Hey guys, so today we're going to go ahead and cover Unit 9, Day 2, Part 1 notes. So this is just a continuation of correlation, okay? But instead of just looking at graphs or looking at tables and then graphing them to see the scatter plot and basically try to see what type of correlation it has, we are going to use something called a correlation coefficient. And a correlation coefficient actually tells us whether we have, a high positive, a low positive, strong positive, weak positive. Same thing with the negative correlations, or if we have something closer to no correlation. And if you notice up here, I've given you the examples from a perfect positive correlation, which is basically, you know, data points that when you graph on a scatter plot will form basically a perfect linear line, which is what we're used to, okay, from linear functions. And then, of course, if you keep going down, you have your high positive, which you can still see is a positive correlation. The only thing is that the dots are a little bit further away from each other. And then if you have a low positive, it's still positive correlation because the points are increasing or they're headed in a positive direction, yet the points are a little bit further away from each other. And then, of course, you get to no correlation. And then, if you move on to the other side, you have your perfect negative, followed by a high negative, which is still decreasing, but the dots are a little bit further apart. And then, of course, your low negative. If you're having a hard time, you could always draw a line. Okay, and I'm going to quickly go ahead and draw these lines. So give me a second. And this will allow you to see okay, so here we go. So if you notice, when we have a perfect positive, literally if you draw a line, the line is going through all the dots. Okay, it's a perfect match. When you have a high positive, this line of best fit fits the pattern, which is positive, but the dots are a little bit further apart from that line, okay? And then if you look at the low positive, the dots are a little bit further away from that same line, okay? So that's why we have a low correlation, high correlation, and then the same idea occurs over here with the negatives. If you look at no correlation, there's no way that we could draw a positive or a negative line or a line with a positive or a negative slope or positive or negative correlation to indicate no correlation. Now, what we're going to do is we're going to be finding um, the correlation coefficient for different tables. Now, if you have a positive one, that's known as a perfect positive correlation. Somewhere between zero point 0.9 will be a high positive, and then low positive will be somewhere around zero point 0.5. And then, of course, if you have no correlation, that's zero. And then the closer you get to -1, that's headed towards a positive or a perfect negative correlation. Okay, so I've provided these examples to kind of show you where these different coefficient correlations fall on the scheme of things. Okay, so let's go ahead. We are going to do number one, but I'm going to skip that one. And let's go ahead and do number two, which is the one on the back. The reason I'm deciding to do this one first is because it is a big table and it's going to take us a minute to type it in. So I went ahead and typed in this table, okay? Now remember, if you want to click add a table, you click the little plus and then click the tab that says table. Now remember, we are creating a line that best matches these data points, okay? So just like when we did quadratic equations and we were trying to create an equation from a table, we're going to have to type that in. And if you remember back when we were doing, creating those y equals mx plus b equations from tables using the yellow calculators, we would go to stat edit, type it in, then stat calculate, option number 4, enter, enter, enter. Here we're gonna have, all we have to do is basically type this slope intercept form, but we're gonna say y subscript of 1, then a little curly symbol instead of an equal symbol, m x subscript of 1 plus b. If we type this in, into the next line on Desmos, it will automatically give me the line of best fit, or the linear function equation, the slope-intercept form equation, and it's also going to give me that correlation coefficient. Okay, so let's go ahead and type that in. So we're going to type in y subscript of 1. So if you click here, the one that says a to the subscript of b, go back to the numbers and click 1. That should give you 1 subscript, or y subscript of 1. And then click ABC again, and then click the little curly symbol, and then MX, make sure you scroll over once because you will make a mistake. There we go, that looks better. MX, then click the subscript of 1, and then scroll over, plus B. Okay? And now that I have that information, it gave me the line of best fit. So the line, the linear function, or the line that best fits this data. Okay? So now, looking at the information that they gave you, the only thing we care for is the R equals 0.9707. The R equals is your correlation coefficient. Don't worry about the R square. Don't worry about the residuals. Don't worry about anything else. The only thing you care about right now, because you're looking for the correlation coefficient, is the R equals. So therefore my correlation coefficient is 0.9707, which is answer choice D. Of course, if we take that correlation coefficient and go back to our little examples at the top, 0.97 will fall in between here. So we're really close to +1. So that means this table represents almost a perfect positive correlation. It's a very, very high positive correlation, okay? We're not there at the perfect correlation, but we're really close to it, okay? So there you go. And of course, if you didn't want to use any of these correlations or any of these coefficients, you could always just look at the graph and try to see, okay? Next one, number 1. What is the approximate value of the correlation coefficient when the data set below is modeled by its linear best fit equation? So once again, I am going to take the moment and I'm going to add a table. And let me change a couple things real quick. There we go. So let's go ahead and type in that table. 25, 49, okay, 26, 24, 27, 60, 55, 61. Okay, so there we go. There's my table. Now, if we look at the information they gave me, is the coefficient or correlation coefficient is 0.68. Okay, 0.6807. So the answer will be C. And of course, if we go back over here, this coefficient falls between the high and the low. So we're almost looking at almost a little bit above low. So, we might say this is a middle core, not strong, not high, not low. It just falls right in the middle, okay? But basically today's lesson, all you're going to do is look at tables and then type in your tables into Desmos and make sure you type in y subscript of 1, curly symbol, mx subscript of 1 plus b to get your correlation coefficient, okay? Don't worry about the rest. Don't even worry about your M and your B, your slope and your y-intercept, which is also given right here, okay? So if you have any questions, just let me know.